Welcome ladies and gentlemen to the flight TJ4M1-02. Before we take off today, we'll be looking at how this aircraft works. Before we begin, we're pilots Callum McKelvey and Anaf Shahid. First, let's look at the nitty-gritty, the bare bones of this hovercraft. What is it actually made of? What are the individual parts? To start off, let's look at the most powerful component at our disposal, 11.1 volt 1600 mAh battery. Now, many of you sensible viewers out there may be thinking that this is overkill, and we could have just done with a 5 volt battery even. And to that I say, you are absolutely correct. But looking at our next component may justify our reasoning. Now we move on to the big daddy of the operation, the brushless motors, powerful enough to challenge the strength of a fully matured Bengal tiger. We had to utilize 3 of these, 2 to lift the craft and 1 to propel it forward. When we saw the motors at their full speed, I kid you not, we feared for our lives because of the vicious sounds it made and how quickly it moved. Now, you may ask, how does one tame such a beast? Electronic speed controllers. Now, electronic speed controllers, as the name may suggest, help us control the speed of the brushless motors. It also lowers the voltage of the battery from 11.1 volts to 5 volts, as the Arduino could not handle that much voltage, so this is a very handy side purpose of the ESC. A servo motor is less powerful, yet very simple motor to control the direction of the rudders and therefore the direction of the entire hovercraft. With so many parts, the problem arises, how do we connect them all together? Well, a Dean's connector was a solution, which connected the brushless motors to the ESCs. A breadboard was used to further organize the wires and house components such as the HC05 Bluetooth module. And the HC05 Bluetooth module allowed us to communicate with the hovercraft, using our phones to talk with the hovercraft. And the brains of this hovercraft was an Arduino Uno board, which was used to receive and transmit signals from the Bluetooth module and send out commands to the motors. For the more superficial parts of the hovercraft, we used 3D printing to make the shell of it and also the fans. Now, what was going on behind the scenes? What was the code that was programmed into the Uno board that would send out commands to all the other parts? For the variable and library declaration of the code, we needed to include 2 libraries, one to control the motors and one to control the Bluetooth module. The software serial myserial part declares the receiving and transmitting pins of the Bluetooth module. The servo myservo part declares that there is a servo motor that needs to be controlled. The servo DESC part says that there is a drive brushless motors that needs to be controlled, and the servo LESC parts declare that there is a lift brushless motor that needs to be controlled. Our variables include the position variable, which would be the position of the servo motor and the rudder, our count variable, which would control the servo motor and the rudder by increments. It has initial position of 90 degrees, and the character command variable, which would be commands that would be receiving from the Bluetooth module. Now for the void setup, we see that my servo attach is declared on pin 11 on the Arduino board. Serial begin allows us to communicate with the computer to the Arduino board. My serial begin also does the same. My servo write.count puts the servo motor in its initial position of 90 degree, and DSC attach and LESC attach puts it at pins 9 and 10 respectively, with a minimum frequency of 1000 and maximum frequency of 2000. Now in our void loop, there is a lot to digest here, but we'll give you 2 main parts which basically summarizes what our hovercraft essentially does. We begin with an if statement, which essentially says that if there is a Bluetooth signal available, which there always is, they'll get a command from that app, and that command will be read by the Arduino. This block of code helps us control the servo motor and the direction of the hovercraft. Now if the Bluetooth module receives the signal A from the Bluetooth app, then it will initiate the while loop. Now our app works so that while you're holding down the button, it will keep giving a command of A, and once you release it, it will go to 0. So that's why it says while command not equals to 0, the following code will initiate. So the count variable goes up by 1, so it will increment the count variable by 1, and the direction of the motor will go right or left depending on which button is pressed, command A or command B. Now this block of code helps control the brushless motors, and it works in a pretty similar way to the servo motor. If the command X or Y is pressed, then the drive or lift motors will increase or decrease in speed. Those are all the essential elements of our code. Now for the fun part, for some live testing of the actual hovercraft.
Idle my room, but you know what? Yeah, I'm controlling this with my phone. I can't wait to show you what I'm doing. Alright, this is the double motor test. We're gonna give this a try and see if everything works out. Yep, both motors are going. And I can steer the back plate, which is good. I'll see if I can hover it for a sec. Oh my god, so it is hovering and it's coming off the desk. I'm gonna just turn it off and I'll try. Once I get the last motor hooked up and wired and ready to go, we're gonna fully test the system out.
One more thing before we move on, we also make sure we have a plastic skirt so the air created by the fans creates a good flow and the hovercraft can actually lift off. Also take a second to look at the Bluetooth app which we use to control the hovercraft. And after all of that, we can bask in the glory of our final product. Happy flying, everyone!
Alright, let's give this thing the grand test. So we'll turn on the middle full. Alright, look at that, it worked! Woo!